The next set construction that we're going to learn about is Cartesian products. The elements of Cartesian products are things called ordered pairs, so I'm going to begin by defining those. And ordered pairs are things defined by a special property that they possess. Specifically, if you have two ordered pairs, so the ordered pair made from the elements A, B, and the ordered pair made from the elements C, D, then those two things are equal if and only if A equals C and B equals D. Now it's possible to construct these things in just ordinary set theory, so only using sets as we've seen so far. But we're going to regard these as a kind of special new type of thing, defined by having this property which is called the ordered pair property. It's probably not an unfamiliar thing to you. If you've come across vectors, for example, before, or coordinates, or r squared, which is the set of all column vectors of height 2 with real number entries, then this has elements of R2 have this ordered pair property. So we often write them as column vectors like this, A, B, and C, D. And of course it's true that A, B, the vector, equals the vector C, D, if and only if, that's what if with two F's is short for, A equals C, and B equals D. So these are the kind of objects we're talking about here. It's worth noting that we can't just use the set containing A and B to represent an ordered pair, because as we've seen before, sets don't have this, the property of being ordered. So we can't use sets for this, because for example, the set containing A and B is equal to the set containing B and A. So sets of two elements don't have this ordered pair property. We need to create a new kind of object which does have this ordered property. Now we know what an ordered pair is, or at least how an ordered pair behaves, we're able to define the Cartesian product of two sets. If you have two sets x and y, then their Cartesian product, which is written like this and pronounced x cross y, or x times y, is the set of all ordered pairs where the first element comes from x and the second element comes from y. Now these ordered pairs have a special property before we look at an example. They have a property to do with the size of these sets, which is that the size of the Cartesian product of x and y is equal to the size of x times the size of y. Let's look at an example to see why that's true. So in my example, x is the set containing 1 and 2, and y is the set containing 2 and 3. In that case, the Cartesian product, x times y, is the set of all ordered pairs where the first element is either 1 or 2, and the second element is either 2 or 3. So specifically that will give us 1, 2, 1, 3, 2, 2, and 2, 3. So you can see there that we had x a set of size 2, y a set of size 2, and then that gave us two choices for the first element of the ordered pair and two choices for the second, giving a total of 4 elements in the Cartesian product, which is of course equal to the size of x times the size of y, because we were able to choose the first element of the ordered pair freely and we had size of x choices for that, and we were able to choose the second element of the ordered pair freely and there was size of y choices for that second element.